we're gonna see the actual loading capability of an AquaBlox.
Yeah.
This is awesome. Science at its finest. We're over 4,000 pounds right now. He's going all out. Actually, the bottom pallet's breaking. Oh, come here, hold it, hold up. No! Hey, what's up everybody? Ed the Pond Professor here. I am coming to you from my office, St. Charles, Illinois, the water garden capital of the world. I have a really cool project that we're going to be showcasing today. It is called the CSL, or the Center for Sustainable Landscaping. I did this project 8 years ago now, which just still blows my mind. But the reason it sticks out is this was one incredible project from the standpoint of it was a first of its kind. It's the greenest building in the world. What it has is all the latest technology for stormwater management, on-site power generation, phytoremediation techniques for cleaning dirty water, permeable pavement, rain gardens, sustainable materials, recycled materials, all the latest construction methodology put together in one project. The reason they did this is they wanted to create a place where people can go and they could see all these different strategies actually implemented. So it's designed for designers, builders, architects, engineers, so they could see all these individual pieces and parts. So what I've done is I put together a little presentation to explain to you some of those parts that we were actually involved in. But what I want to start with first.
This is a very impromptu and interruption to your video. Brian Helfrich and myself are excited to announce the Aquascape Hands-On Academy. And this is the hands-on area right here. This was originally created for the Sandbox Studio for the Aquascape Artists of the Year, but it's going to be turned into a training academy for all people that want to be contractors to come and learn with our crew.
You're going to see Chris, our crew, and how they build a one-day pond, and we're going to show you how to do it in 4 hours.
We're going to have bleachers over here. People are going to be able to get inside, get their hands dirty. Besides the 11 by 16 or 8 by 11, whatever we decide to do for the one-day pond, we're also going to put in fountainscapes and a pondless waterfall. Come to the Aquascape Hands-On Training Academy this winter and work with us in a sandbox, actually getting your hands dirty and learning how to have a career with water features.
Don't you want to tell them about the other day? It's 2 days!
The classroom day. One day is going to be hands-on in the sandbox. The other day is going to be how to actually run a water feature business. Everything you need to know, 30 years of experience, 26 years at the helm, building water features, designing water features, selling water features, marketing water features, promoting water features, everything to do with running a water feature business.
You said a lot in a short amount of time.
We're gonna have a lot in 2 days. Register, check out the link below. And now, back to the vlog.
Is a little bit of a showcase of Aqualand itself, and the reason I'm doing that is because it itself is also a LEED certified building. A LEED certification is known as Leadership in Environmental Energy and Design, and basically what that means is we've utilized a lot of strategies to lessen our footprint on the earth. So you can see here in this picture, our building is dominated by this massive green roof over here. So this is a living roof system that's actually on top of our building, which is very important from stormwater management, as well as creating an incredible insulating barrier on top of our building to help cut back on heating and cooling costs. In fact, we're in the process of redoing that green roof literally as we speak. So if you hear any noise up there, it's actually the crew that's above that's starting the construction processes. Our facility has been installed now for 15 years, and now there's new technology, so we want to jump on it first and we want to update it so we have the best stuff on our facility, because the reason why is we want to live it. We want to showcase it, and it's exactly what the CSL did. It's exactly what we do as well. So you could also see here we have our massive signature water feature in the front, 600,000 gallons of water. We have permeable pavement, rain gardens, we have recycled materials. We have a lot of that stuff as well in our facility. But that other project, the CSL, unbelievable. I'm telling you right now, this facility is amazing. I love the overall design. Recycled facade over here is really cool. This is the original Phipps Conservatory over here, and we're actually capturing rainwater. So when it rains, that water is going to fall on the roof of that building. It's going to flow down through a set of catchment systems, and it comes in right over here in this corner. And then it enters what we call the stormwater lagoon. And I'm going to break all this stuff down, but the picture that you're looking at is actually kind of a living, breathing design system. So it's designed to kind of heal itself and to manage stormwater, and it produces its own power system. I want to start out with water in our environment. It's so common, it's around us all the time, we actually take it for granted. I want to talk about rainwater harvesting. This is a very simple technique that has been used for thousands of years. The problem is years, we've kind of gone away from it. We have centralized stormwater management systems. So what I want to talk about is a decentralized. So that means we're managing it on site. I also want to talk very, very briefly about phytoremediation techniques, which are basically wetland filters. I do believe it's a cornerstone in providing clean and clear water. And then I also want to hit the project overview of the CSL before I actually go out there, so you have a better understanding of exactly what this project is like. So let's start out with that water cycle, the process of evaporation. So we have sunlight coming down, hits the surface of water bodies. It also produces through the process of photosynthesis. So you have sunlight hitting water itself. You also have sunlight hitting green plants. They're going to take water up into the atmosphere through evaporation and also through the process of evaporative transpiration. We have some obviously prevailing winds are going to be coming in, and what happens is that water vapor rises up into the upper atmosphere and it cools off. As it cools off, it condenses, and when it condenses, it comes down in the form of precipitation, rain, snow, fog, a lot of different ways it's going to come back down. This is how our world works. It's responsible for all the weather patterns literally around the world. Rainwater is actually a very, very clean source of water. It's distilled water. It's evaporated literally from our oceans as well as our groundwater systems, goes up into the air. So it's literally distilled water vapor. What happens because of the unique properties of water, as soon as it hits the ground, it starts picking up fertilizers, pesticides, bacterias, pathogens, because water is known as the universal solvent. So more compounds will dissolve in water than any other compound on planet Earth. And then it goes into, it either soaks into subsoils, or it goes directly into rivers and streams and eventually makes its way back to the ocean. Again, simple stuff. When you start paying attention to it, you'll really be blown away by actually what is actually happening on a daily basis. So trillions of tons of water go up into the atmosphere every day. It's a huge number. Problem here is, in a perfectly pristine environment, mountains, streams, forests, and things like that, it literally is going to give life back into all those things. What happens in our urbanized and suburban lifestyles is water falls on concrete, asphalt, roadways, parking lots, rooftops, impermeable surfaces. It's going to turn into runoff. It does not allow water to go into the subsoil. It runs it off into our river systems very, very quickly through storm sewers. It's carrying with it lots of pollutants. The number one source of coastal pollution. That's a big thing to say, and that's because it happens everywhere. So if we can start to better understand it, if we could start to implement some of these decentralized solutions, we can actually make a difference in our environment. So a couple strategies that we could implement. Permeable pavement, I think it's an easy one. When you fly into O'Hare Airport, you look across the city of Chicago, it's concrete, asphalt roof. It's impermeable. So that means it has runoff. So when water falls on it, it literally is going to run off very, very quickly. It does not soak down into the subsoils. So this is causing two problems. One, as I said, it's picking up pollutants. The second problem it's actually causing is it's not replenishing the groundwater system. So this is permeable in this application here. So what happens is water can soak down through all these different little joints over here, and it could go back into the groundwater system. That's a natural cleansing action. So any pollutants that are actually on top of these pavers is actually going to be pre-filtered out and detoxified through bacterial action, through fungi, and through microorganisms that are actually living in and around these soil layers. So this is an important part of the filtration. It's also going to soak that water back down into those groundwater reserves, keeping it out of our storm sewers. So the project we did at the CSL has a lot of this stuff, but what we did underneath our permeable pavement is actually going to be a hollow storage system. We are going to use our AquaBlox. So when it rains, it actually goes and it fills up this hidden underground reservoir, which is really, really cool. So this is a schematic of exactly what we're doing. You can see here we have rainwater coming in, so we have all that precipitation coming down. Underneath that permeable pavement, we have an impermeable rubber membrane. So we have a layer of crushed rock. It's going to allow that water to be filtered, pre-filtered, flows through all that stone, hits that impermeable membrane, and it routes the water into our underground reservoir system. Once we have that water captured, now we could also reuse it in our decorative little fountain over here. So we have a pump down here at the bottom. We have our decorative water feature supplying this natural aeration and oxygenation, as well as filtration for all the stored water. Then as we need it, we split this line off right over here, and it goes directly into our booster pump. Once we send it to the booster pump, we can pressurize that water, and we could use it for irrigation of all the plant material in and around that property. So this is an incredible usage of a valuable resource. I want to show you what some of these AquaBlox look like, because we're going to be putting these blocks underneath a parking lot. So I want to see exactly how strong they are. Let's go take a walk.
So these are a modular system. They come together in a series of panels. We build them directly on site. They're made out of recycled polypropylene. They actually can handle very, very large weights, approximately 34 psi. That's in a confined installation. What I mean by confined is it's buried underground. It has pressure, compression all the way around the outside perimeter. That's gonna hold everything in tighter. This is basically just freestanding. It's gonna be sitting on top of grade. What we're gonna do is we're gonna take this large super sack of gravel, we're gonna place that on top, see how it holds up, then we're gonna start layering more stuff on top of it, because I actually wanna see for myself when this thing's gonna fail. All right, Dan, let's bring it in. First 2,000 pounds are in place. I didn't even hear a creak out of that AquaBlox. So you can see here, this is filled with granite gravel. A full bag of this weighs a little over 3,000 pounds. This is about 75% full. That's why I'm guessing it's about 2,000 pounds. And for our test, it's good enough. All right, let's grab it. Let's get a boulder. You got a big rock? Or do you want to put a big slab on? The next rock we're picking out, another big slab of stone. This is over 2,000 pounds. So we're gonna be at 2 tons on one AquaBlox. Our biggest challenge is actually keeping the load centered, because we have all of it on one. If you look at that, it's kind of precarious. Now we're having fun.
Yeah.
This is awesome. I love this type of stuff. All right, go with another one. This is what will destroy it. So this, when you start moving stuff around, that's a live load. So that's when you have movement. So machines driving over, we're using these AquaBlox at Phipps underneath the parking lot. This is getting 80,000 pound trucks are driving over the top of it on top of plastic crates. Unbelievable what happens when you engineer things together in the right configuration. We're over 4,000 pounds right now. So we have about 20 cubic feet of river rock, and then we have that huge slab on top. And this guy is over 2,000 pounds. This rock right here is over a foot thick. One section, a 1 foot by 1 foot section of this rock is gonna weigh 150 pounds. He's going all out. You just want to put this out to an end, don't you? That's over 3,000. And the reason it's gonna fail is because look at the angles. So it's gonna put a weird loading on that block. Oh, actually the bottom pallet's breaking. Yeah, oh, come here, hold up. Look at the deflection inside of there. It's the pallet is crushing. Oh, awesome, yes. Awesome! That is great. I love this stuff. That was it. That's what we were going for. A science at its finest. You know it. But if you notice how it failed was because we did not have even pressure. So now if we want to redo this test, I guarantee we can get better results, because if I put a plate over the top of that to spread the load out, it would totally change the equation. But we had, let's see, 1, 2, 3.5, pushing 4 tons of stone, which is a lot. So 8,000 pounds, and we had pressure points. That's what destroyed it. So now we're gonna do kind of a reconstruction of actually what happened to cause this failure. Look at these panels are actually fine, the top and the bottom. So what happened, you see the debris that kind of shot out on the side? So we had that load right in the center, and that's because the way the pallet was situated, we had a point load in the middle. The actual pallet was actually bending around it. It's because we didn't have it supported on the outside. So we had all of that weight was really concentrated in one section. So now we're deflecting in, and what it's gonna do, it's gonna start pushing in, it's gonna start blowing out those ends, and that's exactly what happened here. It went in the middle, it just blew out those middle sections, and that is the result. But the top and the bottom are actually totally fine. And these are cracked in half. So again, when it went down, it buckled everything. Weight-wise, six, yeah, between 2.5. 5,000 pounds. Keep it going.
Oh, I heard something. Ah!
Oh! So that actually failed faster than I thought.
And it tipped forward.
It tipped forward. So you know what's happening? Didn't even look at it. This is all pitched. So we didn't have a level base, and this all goes into that sub-base stuff. So when we take our time leveling everything out, doing that sand sub-base, getting it nice and level, it distributes the load evenly. So what we had this one little block. It was leaning probably a little bit forward. We start loading it, and all of a sudden it starts creeping just a little bit. Wind picks up, whatever it happens to be, and all of a sudden, smash, it lets go. The other thing that's actually happening here, this is an unconfined test. A confined test means it's totally held in place, it's tight. We would be able to go twice as much easily before seeing any failure. That might be for a separate vlog, because this is cool stuff. So what actually broke first? Now I'm actually questioning it. I had my back to it. Did the rock actually break from all the weight on top, and then that forced everything to fold around it? This is kind of interesting to me. What actually caused? This is an 8-inch thick slab of stone. It snapped at the exact same time. I don't know which one happened first. This raises a lot of questions.
Oh my gosh, I hope you guys enjoyed that. That was awesome. I was blown away by stacking up all those big rocks on top of the AquaBlox, watching exactly how that system actually is designed, as well as crushed and failed under the extreme weight of all those boulders. But what we're doing on the CSL project is what I showed you was unrestrained AquaBlox. So that was literally a block sitting on top of the ground. Wasn't even level, which was one of the points of failure, but it's not restrained. So what happens is when you put a load on top, it literally just wants to blow it outward. So by restraining it, by putting it into the ground, putting a geotextile around it, filling around it with crushed rock, it's going to put that block under compression. It's going to put it underneath a load. So what happens is it increases the load bearing capacity to a completely different level, which is exactly what we need to do underneath these parking lots. So as I said, once I have all that water captured and stored, we have to filter it. Now, a project of the magnitude of the CSL, the Center for Sustainable Landscapes, has a huge volume of water, so we need a massive customized filtration system. You've seen me install these before. This is a phytoremediation system, which is a wetland filter. We have high velocity water coming in, settlement chamber on the bottom, then we have all that water flowing up through our gravel media to be broken down by bacteria and microorganisms. Here's a better diagram of the actual CSL. You can see over here we have this parking lot area. This is our underground tanks. So we have the roof of the structure over here. We're going to capture all this water. It goes all the way down into our stormwater lagoon. This overflows into a series of different treatment processes. It's kind of a treatment train effect. And what I mean by that is there's several different cells and options that are all going to be working together to deliver this incredible water. This overflows into a series of rain gardens and eventually overflows into that incredible ravine system on the back side of the center. We're also taking some extra water and putting it into a secondary reservoir for later usage. Green roof over on this side. This is all permeable pavement, so we're utilizing all these different strategies, which is what I love about this project. So You don't have to do all these strategies. If you just implemented one of them, it would make a huge difference in the overall environment, as well as keeping some of these valuable resources for future generations, which I believe is very, very important, obviously, for us all. Because our world population continues to grow, we have to make sure that we have adequate resources for future generations to have the same lifestyle that we have. So here are a few pictures of this installation. You can see the building over here under construction. Here's the big conservatory over in the background, which is existing, but we have all these AquaBlox going in. We're storing almost 90,000 gallons of water. We have a huge rubber membrane. You can see this membrane all through here. We're stacking up these blocks to create this massive system. And then on top of that is going to be our permeable pavement system. Because once we get on the site, you're going to probably notice a few of these. These are inspection ports. So you can see all this stuff starting to come together, but it's still difficult to visualize how it's all going to end up. You can see our tank is almost all the way completed over here. Then we have another lower tank over on this side responsible for the infiltration. So remember, water stores in this one here. So this is all water storage. This overflows this way. This is all infiltration. This eventually overflows out and it goes into that stormwater ravine. This is our stormwater lagoon. The input of all that water is coming through a pipe system over here, goes into our wetland filter. So this is our massive wetland filter, almost 200 feet long. We have a couple access points over here. You can see some snorkels that are hidden in here, but we're dispersing water through all of this stuff. And then the water flows back into this lagoon, delivering that incredible water quality. Here you can see the project kind of progressing along a little bit. You could still see the reason I kept this picture is to point out some of these inspection ports, because those are going to be visible all the way through the completion of the project. On top of all those AquaBlox, we have all this crushed stone over here. Then on top of this will eventually be the permeable pavement, which is going to finish everything off. And then all of this will be filled with lush plantings going all through this entire area that are going to send their root systems down into that stormwater system to help absorb all of those pollutants and nutrients to really finish this project off. So this entire concept is the decentralized solution. Instead of pushing all the water away into a stormwater system, keeping it on site, managing the water, utilizing it, and then reusing it in and around the facility for non-potable water use. So that means anything other than drinking. So it could be for flushing toilets, for irrigation, for outdoor washing, for manufacturing facilities. Any of these things don't need to have drinking water. So this is an incredible source of water that's falling literally free for you anywhere you live around the world. I hope you enjoyed this project, and I look forward to showing you the actual Center for Sustainable Landscape, because it is phenomenal. Thanks again for watching. We'll see you on the next one.